Okay, college algebra. We continue on with inequalities, and we kind of have a method for how we solve nonlinear inequalities. Again, nonlinear means that you don't have x to the first power. And I showed you a couple ways earlier. I'm going to do my favorite way. I have a quadratic. I'm going to factor to x plus 4 times x minus 2 is less than 0. I have to produce a graph or do a number line test. So as I produce a graph, I plot -4 and +2. I know that this graph goes up because it's a positive x squared. And the question is, where is it less than 0? Where is it negative? Well, it's positive here, it's positive here, it's negative down here. So that means it's below the x-axis from -4 to +2. And that's my solution. So you can see how quickly it goes. I don't like to do them if they have a negative in front, so I multiply through by a negative, and I get 2x squared minus 7x plus 5 is greater than or equal to 0. And that does factor. And remember to switch the sign on that, but it factors. We put a -5 and we put a -1. So 5 halves and 1 are my solutions. So if you were to graph that, we plot 1 and we plot 5 halves, which is 2.5. We draw the graph. You might say, well, it's negative. Well, I switched it, so I'm using this one right here. We're wondering, where is it greater than 0 or equal to 0? Well, it's positive there, it's negative down there. So I'm going to look at that region and at that region. So my solution set in this scenario is from -infinity to 1, bracket, union, bracket, 5 halves to infinity. And there you have it. So what happens if we get things that we don't know what the graph looks like? Well, for letter C, we don't know what that graph looks like. It's a very interesting graph. But the key is that you gather everything on one side, and everything is on one side here. You factor it, it's already factored. And then you go ahead and you begin to look at where it's equal to 0 on the top and on the bottom. Once I have the top and the bottom equal to 0, I take those numbers and I plot them on the number line. And I plot -3. I plot 2. And I plot 4. However many things you have on top, you're going to have one more column and you will have exactly that many rows. So since I have 3 numbers on top, I have 3 rows and I have 3 plus 1 columns. Now, this grid is for me to test whether things are positive or negative. Notice how this inequality right now is set less than 0. I know that the number -3, +2, and +4 give me either 0 in the numerator or 0 in the denominator. But what about the numbers in between? Well, let's test them, okay? On this side over here, I put x minus 2, x minus 4, and x plus 3. You can put them in any order you want, but that's where I do my testing. So for example, I would like to test -4 because it's to the left of -3. And I would plug -4 in for these x values. -4 minus 2 is negative. -4 minus 4 is negative. And -4 plus 3 is negative. I'll test a value between -3 and 2. I'll test 0. And when I plug 0 in for these x's, 0 minus 2 is negative. 0 minus 4 is negative. And 0 plus 3 is positive. Now I'll plug in 3. If I plug in 3, I get a positive because 3 minus 2 is positive. 3 minus 4 is negative. And 3 plus 3 is positive. Now I will try 5. That is to the right of 4. 5 minus 2 is positive. 5 minus 4 is positive. 5 plus 3 is positive. So in this situation, you have a negative times a negative divided by a negative. That's what's occurring up here. You can see multiplying and dividing. So I have that negative times a negative divided by a negative. And that result is negative. Negative, negative, positive. The result is positive. Positive, negative, positive. The result is negative. Positive, positive, positive. Result is positive. So this is wondering where it's less than 0. It is less than 0 wherever it is negative. So in this region it's negative, and in this region it is negative. So therefore, my solution set is from negative infinity to 0, or to, I'm sorry, negative infinity to negative 3, union with 2 to 4. That's my solution set. What we've actually done is if you were to plug this into your graphing calculator and turn this on, y equals, clear those out, and I were to type in x minus 2 times x minus 4, and I were to divide that by x, well, parentheses, x plus 3, and I check out that graph, you're looking for where it is below the x-axis. And it turns out that it is below, over here from 2 all the way over to 4, and then back there as well. I have a phone call coming in, excuse me. So not a real good graphical example, sorry, but we'll put the graphic calculator away and look at a different one. But I just want you guys to know that this is not easy. This is definitely the most difficult part of your next test. You might have to watch this video a couple times, might have to come on in, but solving these nonlinear inequalities, it is important, especially as we get to calculus, these questions come up. Let's look at your next one. Again, everything's gathered to one side, and in this situation, you have a you can see that as I make my number line, I have a 0, I have a 5, I have a negative 2, and I have a 10/3. And so as I plot those, I got negative 2, got 0, got 10/3, got 5. Because I have 4 numbers on top, I'm going to have one more column. So I'm going to have 5 columns. Since you have 4 numbers on top, you're going to have 4 rows. And that's how I make my chart for my testing purposes. On this side, I put the factors of negative 3x. I put x plus 5. X minus 5. X plus 2. And 3x minus 10. So there we have it. Now, let's test some numbers. I'm going to test negative 3. Negative 3 sits to the left of negative 2. I would get a positive, a negative, and a negative. I'll try negative 1. I get a positive, a negative, a positive, and a negative. I try 1. And again, if you're wondering what I'm doing, I'm taking 1 and I'm plugging it in for x down here. Negative 3 times 1 is negative. 1 minus 5 is negative. 1 plus 2 is positive. And 3 times 1 is 3, minus 10 is negative. Try plugging in 4. I get a negative. I get a negative. I get a positive. I get a positive. And I try plugging in 6. I get a negative. I get a positive. Get a positive and a positive. So you can see that a positive times a negative times a negative times a negative, I get a negative. If it's an odd number of negatives, it's negative. If it's an even number of negatives, it's positive. Notice how the positives do not really have anything to do with changing the sign, rather just the negatives. The question is now at this point, where is it greater than or equal to 0? And so it's greater than or equal to 0 wherever it's positive. And so right now you're saying, well, we're going to go there, and we're going to go there. And so you have -2 to 0, and you have 10/3 to 5. And right now, because you see the equal sign, you want to put brackets around it. And that's where, unfortunately, we are not correct. You see, one small thing that you have to consider is you can never have 0 in the denominator. And what number would give you 0 in the denominator? -2 would, and also 10/3 would. So as you go back, you cannot include anything that gives you 0 in the denominator. So -2, whoops, sorry, -2 to 0, union with 10/3 to 5. Now that is our solution. Again, I know that this is not easy, but I know you're extremely intelligent people. We're going to work on this in class together, and then you're also going to have the chance to come and see me for help as well. This one is different because it doesn't have 0 on the other side. So what I do is I start by subtracting the 2 over. Second of all, I find common denominators. I have to multiply top and bottom by 2x plus 3. Greater than or equal to 0. Now I have 4x minus 6 all over 2x plus 3 is greater than or equal to 0. Notice the 4x's cancel. I have a -6 left in the top. I'm going to tell you that if you end up with a negative, multiply through to make it positive. It's just a lot easier. It's tough in the video to get into why that's important, but it is. So nothing makes 0 on the top, but -3/2 makes 0 in the denominator. So in this situation, I just have one spot that I plot, -3/2. That means that I will have 2 columns. I will have 1 row. Notice you don't have to put anything for the 6 because the 6 does not have a factor that involves an x. There's no solution that gives you 0 in the numerator. So I simply just test 2x plus 3. I'm going to plug in a number to the left of -3/2, which would be -2. 2 times -2 is -4, plus 3 is a negative. Then I plug in 0. 2 times 0 plus 3 is a positive. According to the sign, I'm wondering, where is this less than or equal to 0, or where is it negative? It is negative there. So from -infinity to -3/2. Now let's see, do we put a bracket or do we put a parenthesis? This sign says I want to put a bracket, but that would give me 0 in the denominator, so parenthesis. Last one. Again, it's not less than or equal to 0, so I'm going to subtract over the 3x. I will multiply the top and bottom by x plus 1 to get the common denominator. And when I do, I have x minus 3x squared minus 3x over x plus 1. Or -3x squared minus 2x over x plus 1. And again, those are both less than 0. I don't like the negative. I'm going to multiply through to get rid of it. 3x squared plus 2x over x plus 1 greater than 0. And so now we factor. As you take out the x, you're left with 3x plus 2. I am now going to plot. Be a 0 here, be a -1 here, be a negative 2/3 up there. So I'll plot -1, negative 2/3, and 0. There are 3 numbers, so I will have 4 columns. 3 numbers, so 3 rows. Place the x, place the 3x plus 2, I place the x plus 1. Now it is time to test. I'll test a number to the left of -1. I test -2. It is a negative, negative, negative. A number between -1 and -2/3, or a number between -1 and -0.6 repeating. I would like to try -0.9. I think that that's an easy number to plug in. That would be negative. 3 times -0.9 is -2.7, plus 2 would be a negative. And -0.9 plus 1, that would be a positive. I'm now going to plug in a number between -2/3 and 0. I'm going to plug in -0.1. So I plug in -0.1. I get a negative. I get a positive. I get a positive. And finally, if you plug in a number to the left of 0, say 1, you get a positive, positive, and a positive. 3 negatives make a negative. 2 negatives make a positive. 1 negative makes a negative. 3 positives make a positive. So the question is you look at how you finish this off, where is it greater than 0? It's greater than 0 wherever it is positive. There's no equal sign, so nothing concerning putting brackets at all. -1 to -2/3, union 0 to infinity. Now, maybe this one actually gives us a better graph. Again, these things we don't know what the graph looks like. The quadratics we did. But if I were to type this in, 3x plus 2 divided by parentheses x plus 1, and I were to look at that graph, sure enough, as I have my trace button on here, you can see kind of the cursor following. Down there, it's negative, and the x value is -1.7. So all the way until we get to -1, it stays below. But when we get to, look at now, we got -0.85. Now the cursor's above the x-axis. We move to the right, -0.63. That's past -0.66. So now I'm sitting below all the way until I get to 0. You can see it's still below until I go over to 0. And now after that, it's above the x-axis. So you're really determining where that function sits above and below the x-axis. Challenging lesson, long video. We're going to take time in class. Trust me, I know we need to work our way through this. If you want me to reteach it to you one day after school, I'd be happy to do that. But this is something that is important. And just know that the rest of the unit will all be easier than this. So get through this piece, and I think you're going to find a very good test. Good luck. I can't wait to see you guys.